course, this is Euclid Book 7, Proposition number 2, Part 2. And we were talking about how, in the last part, how 2 was a common measure of both AB and CD. Now we have to prove that it's the greatest common measure. And that's why I wanted to do Part 2. Now, I want you to take a look here. We've added another line. This is line G. This is the reason why I wanted to do a part 2 on this, because we're going to add this line here. It's G, and we're going to say that G equals 4. Okay? Because we're going to use 4 as a measure. Okay. Well, let's go into what Euclid has to say about this. Continuing with the proof, it says, I say next that it is also the greatest. Okay? The CF being 2 is the greatest common measure between A, B, and CD. For if CF is not the greatest common measure of AB, CD, some measure which is greater than CF will measure the numbers A, B, and CD. Let such a number measure them, and let it be G. Now, G is greater than CF because G is the measure of 4, and CF is the measure of 2. Okay? Now, since G measures CD, which technically, G would measure CD, even though it'd leave a remainder, okay? So, you know, you have 4 times 3, which is 12, plus a remainder of 2. So, yes, G would actually measure CD, okay? Even though it'd leave a remainder. Now, since G measures CD while CD measures BE, well, CD, of course, measures BE because 14 times 2 is 28, and BE is, of course, 28. G also measures BE. Well, 4 will go into 28. Okay, 7 times 4 is 28, is it not? But it also measures the whole of BA. Well, four times 8 is 32. Okay? 4 times 8 is 32. So C will also measure AB. Therefore, it will also measure the remainder AE. Well, AE is, of course, 4, and 4 does measure 4. But AE measures DF. Well, 4 does measure DF, which is 12. Therefore, G will also measure DF. Well, 4 will also measure 12. But it also measures the whole CD. Okay, so 4 actually measures 14 with a remainder of 2. Therefore, it will also measure the remainder CF. Now that you've got a problem, because CF is 2. 4 does not measure 2 at all, ever. Okay? The greater will measure the less, which is impossible. I've established that. Therefore, therefore CF is the greatest common measure of A, B, and CD. Now then, Euclid gives a porism. From this, it is manifest that if a number measures 2 numbers, it will also measure their greatest common measure. So, if CF measures A, B, and CD, then CF will also measure their greatest common measure, which in this case also happens to be 2. The greatest common measure being 2, CF being 2, CF definitely measures the greatest common measure, which is 2. And there you have it. That's it. That is Euclid Book 7, Proposition number 2. If you have any questions or comments, leave them down here in the comments section below. I will tell you more in a future video, so stay tuned.